In this video we will look at the source properties of aggregate, that is the properties of the rock that the aggregate is made out of. Each aggregate particle needs to be strong enough to support the load on it without crushing. The load that will crush the aggregate material is called its crushing strength. Aggregate used in road construction needs to have a crushing strength in excess of the loading it will experience in service. If a larger particle crushes, then it becomes a whole lot of smaller particles and the load is not so well distributed. The other coarse particles would be required to carry higher loadings, which may crush them in turn, and so on until the layer is just fine particles and no longer has the mix of aggregate sizes required to make it strong enough to carry the road loadings. The crushing strength of a particular aggregate is determined by the type of rock used to produce the aggregate. Some rock materials are composed of strong materials that are well cemented, while others, such as sandstones, are not so well cemented or are composed of weak materials and are not suitable for use as road aggregates. Other rocks may be made of strong materials, but they may have layers of weak materials or very close fractures in them that make them unsuitable for use as aggregate. The crushing resistance test is carried out on particles that have passed the 13.5mm sieve and are retained on the 9.5mm sieve. In other words, they are between 9.5 and 13.5mm in diameter. The whole aggregate mix would have come from the same rock with the same crushing properties, so all aggregate particles would have the same crushing strength. The particles are loaded into a standard size cylinder and compacted. A plunger then slowly applies a force on the compacted area. It reaches a specified maximum load of 130 kilonewtons after 10 minutes, and then the load is removed. The test material is then sieved, and the amount of material that is broken up is determined as the percentage passing the 2.36mm sieve. Remember that all the aggregate particles were larger than 9.5mm when the test started, so any material passing through the finer sieves would have been from larger particles being broken up. 10ZM4 requires that the percentage passing the 2.36mm sieve should be less than 10% of the total weight. In other words, some of the aggregate particles can break up under the load, but most particles would have carried the weight without crushing. As an aside, 130 kilonewtons is the force that a 13-ton mass would apply, which is about the weight of a medium-sized truck being applied to the area of your size of your hand. So it's quite a significant pressure being applied there. Another test on this source material is CBR. CBR is short for California bearing ratio. It is a measure of the strength of an aggregate or soil layer and can be used in both earthworks and road construction. In earthworks, it is often used to measure the strength of the final subgrade, while in roading it is used to determine the subbase and base course strength. There is a set procedure for the CBR test, so the test provides an accurate indication of how the material will behave under load. The diagram shows the lab setup for the CBR test. The sample, in this case base course, aggregate, is compacted in a container. A plunger is then pushed into the sample at a set rate. The force required to do this is measured and compared to the force required to penetrate a standard material. It's just a reference, but material basically. The CBR is the ratio of the force applied to the sample to the force required for the standard sample. So a CBR of 10 means the force required was 10% of the force required for the standard material or the reference material. A higher CBR value means a stronger layer. For example, soft clay would have a CBR of 5 or lower, a sand would have a CBR of around 10, lime stabilized material has a CBR of 20 to 30, and a base course should have a CBR above 80. This may look a lot like the crushing resistance test that we looked at before, but they differ. The CBR is measuring the resistance of the whole compacted aggregate layer to load, while the crushing resistance test is measuring the strength of individual particles. The CBR test can be done in a lab using a standard compaction procedure to determine how strong the aggregate layer would be in service. This would allow the designer to design the pavement to suit the aggregate strength, and also allows the aggregate supplier to demonstrate that the aggregate they are supplying will meet the specified strength. It would be very expensive to start constructing a pavement layer using an aggregate mix only to find that the material is not able to achieve the required strength, so it is better to do the lab tests first to check. The CBR test may also be used during construction to demonstrate that a compacted aggregate layer has attained the strength required by the road designer. Weathering resistance relates to the resistance of the aggregate particles to the effects of heating, cooling, wetting and drying that will occur as a result of being outside and exposed to all weathers for a long period of time. The sample tested is a mix of aggregate sized between 4.75 and 9.5 millimeters in diameter. The sample is repeatedly wet, dried and then rolled before being boiled and quickly cooled. The sample is then sieved through a 4.75 millimeter sieve to determine what percentage is broken down, and the amount of fine materials produced are also measured. Remember that the aggregate particles were all retained on a 4.75 millimeter sieve at the start of the test, so any material passing the other sieve after the test would have resulted from aggregate particles breaking down. The percentage passing the 4.75 millimeter sieve and the cleanliness determine the weathering quality index of the aggregate, which ranges from AA, which is material having hardly any breakdown of material, through to CC, which has up to or over 10% of the original material breaking down, and some fine particles being found in the water used to wash a sample. 10ZM4 sets out the acceptable weathering quality index as being AA through to CA, or more simply, generally aggregates that have more than 10% of their mass broken down are considered unacceptable unless the broken material is sand-sized particles rather than silts and clays. This is not essential knowledge, but you do need to know what the weathering test actually does and why we do it.